Hey, how's it going? We're going to take a look at 8.4, which is find the sum of an infinite geometric series. Now, when you do this, you have to keep in mind a couple of things. We're going to talk about that in just a minute. But the big thing is you got to pay attention to r. If absolute value of r is greater than 1, then you cannot find the sum of an infinite geometric series. So let's consider infinite geometric series of 2, 2/3, 2/9, 2/27, and so on. In this case, r will equal 1/3. Now, what that means is we will be able to find the sum of infinite geometric series. And we'll get into that a little bit more later. But let's talk about what this series is going to look like when you find the sum of it. So right here, say you just have this table. 1, 2, 3, those are the sum. Those are the values as you add up each sum of the series. Here's position 1, 2, 3, 4, 5, and so on. So my first sum is right there. First position's 1, the sum is 1. Now I'm going to take 2 and add it to 2/3, which is 2 2/3. So I want to say that's right there. Now I take 2 2/3 and add 2/9 to it. So that's going to be like right here. And I take the sum of the first three terms and add 2/27 to it. And what you're going to find out is that this is going to get very, very close to 3, but it will not pass 3. So in this case, 3 is your limit, so the sum is going to approach 3. Write a rule for a sequence, or for this sequence right here. That would be a sub n equals the first term, which is 2, times the ratio, which is 1/3, raised to the n minus 1 power. Here we're finding the sum of the 2, 4, 10, and 20th terms. We talked about this equation a little bit earlier. Now the first two terms are just going to be 2 plus 2/3, so it's going to be 2 2/3. Another way to think about that is 8/3. Now the first four terms means I'm going to look at what the sum of S sub 4 is. Now we have to remember the equation, which is the first term times 1 minus r raised to the nth power, all divided by 1 minus r. So my first term is 2 times 1 minus 1/3 raised to the 4th power divided by 1 minus 1/3. So it's 1 minus r, this is n. Those will be the same number of terms, over 1 minus 1/3. Now if you put that in your calculator, what you get is 80 over 27, which is the same thing as 2.963, or thereabouts. Now we're going to do the same thing for the sum of the first 10 terms, sum of the first 20 terms. S sub 10 equals 2 times 1 minus 1/3 raised to the 10th divided by 1 minus 1/3. That sum is 2.99995. Now what's going to happen when you do the first 20 terms, you can do the same thing, except for this is going to be a 20. And that sum is going to be equal to 2.9 repeated. So as I mentioned earlier, it's going to get closer and closer to 3, but it won't actually hit 3. So what do you notice? Sum is approaching 3. Okay, now, sum of finite or infinite geometric series. If the absolute value of r is less than 1, the sum of infinite geometric series with term a sub 1 and a common ratio r is given by the following. So you can write this as s sub 0 because you're taking a look at all the terms is going to be equal to a sub 1 divided by r minus 1, or 1 minus r. If the absolute value of the ratio is greater than 1, then there's no sum because it's going to keep going up like that as far as your sum is concerned. Down here in these three examples, what we are going to do is we are actually going to find the sum. I'm going from 1 to infinity, 3 times 1/4 raised to the I minus 1 power. Based on our formula, which is right here, r is 1/4. A sub 1 equals, well, if I put 1 into this I, 1 minus 1 is 0, 1/4 of 0 power is 1. So the a sub 1 is going to be equal to 3. So the sum of an infinite series, we can find it because my r is less than the absolute value of 1, is going to be equal to 3, which is my first term, divided by 1 minus 1/4. This is 3 over 3/4. And when you simplify that, you get 4. So going back to this as our illustration, this would be a 4, and my sum would be approaching it. The next one, if you calculate r, remember you're going to take negative 1/8 divided by 1/4. 1/4 divided by negative 1/2 is negative 1/2. A sub 1 happens equal the exact same thing, which is fine. S sub infinity, because I'm going to figure out what all the terms are, the sum of all the terms. First term is negative 1/2 divided by 1 minus a negative 1/2. Gives you negative 1/2 divided by, now this is a double negative, so it becomes positive, 3 over 2. So this is going to equal negative 1/3. That's what my sum is. It's going to approach it, won't actually hit it. It's called a limit, so therefore we can say it does equal it. What I need to do is figure out what r is. 9/4 divided by 3/2. 9 over 4 divided by 3 over 2. I just picked that one. Equals 9/4 times 2/3. That equals 3 over 2, right? That's r. R equals 3 over 2. Therefore, no sum. Because this is not less than 1. Okay, here are a couple examples here in terms of applications of this. Rubber ball is dropped from a height of 60 feet. Each bounce it takes 2/3 of previous height. What is the total vertical distance the ball travels? Now, you got 2 of them here, right? You're going to have a downward distance and you're going to have an upward distance. Ball is going to come down, then it's going to go up. So it's going to come down, go up, come down, go up, and so on. So that's why we have a downward distance and we have an upward distance. Here's down, here's up, and down, up, and so on. So my sum is going to equal, my starting distance is 60 feet divided by 1 minus 2/3. Now this is my coming down distance, right? So 60 divided by 1/3 equals 180. I need to do the same thing with it coming up. S of infinity is going to be 40. Now I got 40 because 2/3 of 60 is 40. 1 minus 2/3 equals 40 over 1/3 equals 120. So the total distance traveled is 300 feet. Take 180 and add it to 120. Okay, next example. The first month that a car door handle assembly line is used, a company finds 80 defective door handles. Since then, the number of defective handles has increased by 7% per month. This trend continues. What are the total number of defective handles the company will make over its lifetime, assuming it continues to stay in operation? So how you got your answer? Well, what we know is that A sub 1 equals 80. Got that from right here. R equals 0.93. It's decreased by 7% per month, which is the same thing as 0.93. This is like taking 1 minus 0.07 to get 0.93. From there, we can use the sum of an infinite geometric series equation. So it's 80 divided by 0.07, which is 1,142.857. So what we're going to say is 1,143 door handles over its lifetime. All right. The sum of infinite geometric series can be used to write repeating decimals as fractions. The key to this is the whole idea of repeating decimals. They have to repeat in order to do this. So write 0.272727 ... as a fraction in lowest terms. Well, what we know is the following. I am going to let R equal 0.0027 divided by 0.27. That's just given to me right here, right? Or right here, right? This equals 0.01. Now, A sub 1 is 0.27. So S sub infinity is going to equal first term, which is 0.27, divided by 1 minus 0.01. So you have 0.27 divided by 0.99. Now this is the same thing as 27 over 99. You can rewrite those same thing. Just multiply top and bottom by 100. Now I can divide 9 into both these numbers, right? So as a fraction, this number as a fraction is 3/11ths. Now we're going to do the same thing here. Notice we repeat 146, 146, 146, and so on. So the 146 is repeated. So that's going to equal 5 plus. Now, I can take 146 and divide it by 999. That's the same idea as we had right here. See how I had this 0.27, write it over 0.99. If it's 3 places, it's going to be over 999, okay? Now you add those together, and you get 5 and 146 over 999. This equals, take and multiply the denominator by the whole number, add the numerator, and you get 5141 over 999. That's this number as a fraction. Let me know if you have any questions on 8.4.